how would you do part C, the bottom one?
So, is this where? Is this where we do calculator and then the equation of x squared minus 3x plus 1, and then when we do start -2, and then end 4, and then step 1, and then the ones that end, is it what the answers that are 3? Then those are the ones that like.
No. So I might as well do this. So that's -1, 5, 5. So let's say -2, 11, 4, 5, and it looks like something like -1.5. So 1.5 and -1.5, maybe. So it goes through 0, 1. Okay. So something like that. So this is y equals x squared minus 3x plus 1. If I was to rearrange this, it would be 3 equals x squared minus 3x plus 1. So how would you solve that? What would you do? So it's quite tricky, you might not get it. So you know how this is the graph of y equals x squared minus 3x plus 1?
Yeah.
So this y equals became 3 equals. So I just wrote it as equals 3. I just wrote it as 3 equals. And so basically you want the two x's where the graph has a y coordinate of 3. So if you go to 3 on the y-axis, it's going to be those 2 points are where it has a y coordinate of 3. So what are the solutions there?
Is that like 3.53 and the other one looks like is it minus 0. Like 2 or 3?
I'd say 3 because it's after, it's halfway between the 0.2 and 0.4 negative. Yeah, so if you have to do a question like this, first you draw the graph, and then they say when is the graph equal to 3? It's the same as the thing from here. X squared minus 3x plus 1, x squared minus 3x plus 1. So this is y equals, this is 3 equals, so basically y became 3. When does the graph have y coordinate of 3?
Okay.
And excuse me. So this is the line y equals 3. And in the same way that if you had like y equals 3 and y equals x squared minus 3x plus 1, you know how if they're both equal to y, you can bring them together.
Yeah.
And so that's what it's like down the bottom. If they're both, you can do the opposite. So you can pull them apart and you can say that's equal to y, that's equal to y. So y equals 3. Where do they cross over? It's like graphical simultaneous equations. This is the fancy way of saying when does it have a y coordinate of 3? Excuse me. So I'll do Yeah, I'll do the first part of this. How do you do part C down the bottom?
Yeah. So
0, 0, 0, etc. So 0, 2, 1, 0. So okay, so it's going to be something like that. Okay, how do we do this one?
I think what I need to do is, do you draw a line plus y equals 4,
Yeah,
and then where you see that like they touched the line, like the little curved line there, then
yeah.
you draw like a line down,
Hmm.
and you do it. And then so I think it's meant to be like, I think x is either 0 like minus 0.4 or or 1.7.
Okay. Yeah, and that's why it says estimates. Any question there?
Okay.
Yes, so here's a slightly trickier one. How do we do the second part for this one? Why did it do that? That's fine. This one 2 minus 1 minus 2. Oh, okay. So 1 across minus 2 looks like the bottom. Minus 2, 7, there. And whatever 4 is, 0 minus 1. Okay. Okay, how do we do this?
So is this kind of like, so where it says x plus 3, does that mean that we just need to add an extra? Does that mean that like wherever like y equals 3 is, you need to add an x or something? Or
It means it means draw the line y equals x plus 3 and see where they cross over. So for these ones, you drew the line y equals 4 because it was equal to 4. For this one, you drew the line y equals 3 because it was equal to 3. Now it's equal to x plus 3. So you draw the line y equals x plus 3. So it's like if you had two graphs. One was y equals x squared minus 2x minus 1. That's this one. The other one was y equals x plus 3.
yeah.
And they're both equal to y, so they brought them together. So now you're just pulling them back apart, seeing where they cross over. So how do you draw the line y equals x plus 3?
I'm not sure.
So how did we draw the graph of this one, x squared minus 2x minus 1?
We took like the number, then we just like did like y. So if it was like just like equals 3, we just do y equals 3.
So for this tricky one, put it in the calculator. For the easy one, put it in the calculator.
Alright.
Alpha x plus 3. Start -1, sure. Stop at 5, sure. And there's a bunch of points on it. -1, 2. -1, 2. What type of graph will this make y equals x plus 3?
What type of graph? Sorry, did you say?
Yeah. So this one makes a curve.
Yeah.
Y equals x plus 3. So you could you could plot all of these points separately, all these x's.
Yeah.
But I know it's a straight line, so you can just do it first and last, or you can do all of them. So there you go. There's y equals x plus 3.
Wait, how did you get that? Sorry.
Excuse me. So I just put it in my calculator. So you know how doing the one up the top, you put it in your calculator and it gives you x and y coordinates, and you just put x's and then you join them up.
Right.
So I did y, or f of x, y equals x plus 3.
Yeah.
And there you go, gives me a bunch of coordinates. I just did the first one and the last one. -1, 2, and the paper doesn't go to 5, so I did 4, 7.
Alright.
And I know it's a straight line, but you could do all the x's if you wanted to. If you weren't sure, the calculator puts all of them in. Okay, what are the solutions?
Is one of the x's minus 0.9? I was looking at the other one, sorry. So is that other one like 3.6 or something?
X equals 3.6, or it looks like x equals minus 0.9, something like that.
Yeah.
That's it. So just draw them as best you can. So it's particularly difficult for me to draw a curve with this thing, but draw it as best you can. Draw the line y equals x plus 3 and then see where they cross over. Yes, and they wanted the x where they cross over. That's it. Any questions about that?
No.
Okay. So yes, it's a good one. Okay, so how do we go about this one? So x squared minus 2x. How do we do the second way?
So am I just doing C?
Yeah.
So do I just is this the bit where I just do like y equals to x squared minus 2x minus 2? Oh no, is this like an easier one because I just need to draw the line across for like y equals 1.
Well, let's see. So what do you notice? So this one up here is x squared minus 2x. They asked you to do x squared minus 2x minus 2 equals 1.
Yeah. Oh, so do I just add the 2 so it's y equals 3?
Well done. Yeah, and then what do you do?
So once you like add once you've got y equals 3, you just sorry, you just look where the other point, like where it like hits the points.
Yeah, exactly. So this one you had to manipulate it a bit to make it the same as the graph you already have. So you got that right away. And so, okay, estimates of solutions. What does it look like?
Looks something like minus 0.8 or 2.9.
That's fine. Yeah. So quite often you have to manipulate it a little bit to make it this. So on one side it's exactly the same as the graph you already have, so that you can use the graph you already have and then just draw another line. Okay. So quite. How about this one? How would you go about this?
So so 2x squared minus 1 equals 0. Do I just find...
Hang on, I didn't draw that correctly at all.
So
I'm trying to just minus. So minus 1, 0, 0 minus 1, of course. Yeah, go on. What do you do with this one?
so do you just find the line of like y equals to 0?
And where is that line?
Is that just the like the line that's like kind of already given to you, like the black line?
Yeah, the x-axis, exactly. So you just say where it crosses the x-axis. That's it. So kind of a strange one, but there you go. Okay, they give you this graph. How would you do part A, part 1?
So is this just where you do? Is this just like draw like the line of like y equals 0?
Yeah.
Yeah.
And see where it crosses over. So what would be one solution for the first one?
One solution would be like 4.2 or 3 or something.
Okay. X equals 4.3, let's say. Or x equals the negative thing. Okay, how about part 2?
X squared minus 4 minus 6 equals 0. So should I like add the 6 to the other side? Or?
So would that make it x squared minus 4x minus 2 equals 0 if you added 6? So you have to add something, so you end up with minus 2.
You need to like. Do you need to add 4?
Yes. And so, what do you do next?
So is this just where you do You just do y equals to 4.
Yeah, and you see where they cross over. And how about part B down the bottom?
Yeah, so alright, so I think that if you did something like 6 minus x is equals to x squared minus 4x minus 2,
Right.
that would probably do something.
So you made it y equals 6 minus x?
Yeah.
So how do you go about then solving those two?
Would you like do 6 minus x equals to x squared minus 4x minus 2? Or
Okay, so how would you use that to then use your graph to then solve it?
I'm not sure.
So you know how first one, you use the line y equals 0.
Yeah.
And then the second one you drew on y equals 4. And
Yeah.
see where they cross over. Well, the third one you draw on y equals 6 minus x. Any idea how you draw y equals 6 minus x?
So, would you do I forgot how we did the last. Oh, we did like a similar question to this.
Well, the way we've been drawing all these curves is by just putting in the calculator. I mean, there's many ways you can do it. 6 minus x. The paper starts at minus 3. Stops over at 8. Step 1. So in minus 3, it's 9. So minus 3 across, 9 up. And 8 minus 2 is there. And so that's one way you could do it. So
you go straight line, don't you?
Yeah. So I know it's a straight line. If you're not sure, because then just do all the x's. So do 7 minus 1 put an x, 6 0 put an x, 5 1 put an x, just like one of these tables. Okay, what's one solution there?
So
Or an estimate?
yeah, so 4.8 or something. Yeah.
Okay, something like that. And you'd use your ruler. Do it as accurately as you can. So x equals 4.8, or x equals, put in the negative one as well, minus 2 or something. Okay, so yeah, that's how you draw y equals 6 minus x. Many ways you can do it. Just put in the calculator and it gives you a bunch of coordinates on the thing. Just put all the x's on, just join them up. Just the same with the curves. You put it in your calculator, it gives you lots of coordinates, and then you just make lots of x's.
Yeah.
Join up. Any questions there?
No.
Okay, so it's a very tricky topic, and these are all the same. Same idea, 6 over x. So 6 over alpha x. You can see there it's exactly the same idea. So this time it starts at 0.5. It ends at 6. That's very unusual that it starts at 0.5. After that it goes up in, I could do steps of 0.5. Will it let me? Yeah, well, okay. So you just put in the answer for 1, 2, 3, 4. And then join them up. And there you go, it looks like that. 4 over x, same thing. 2 to the power of x, so that's an exponential curve. 2 to the power of alpha x, so it looks different, all the same to the calculator. Starts at -2, stops at 3, steps of 1, and there you go. 0.25 is the first one. When x is 1, it's 2, and that's, you just join them up. Put all the x's, join them up. This is transformations, I think we did. Okay, how about this one?
So, is this like...
Sorry?
Yeah. Is it the bit where I like start at 1 or something?
Yes, you start at 1. 0, 1.
Yeah, 0, 1. And then, do you go 0, 90?
Yep.
90, 0, I should say. 90, 0.
Yeah,
yes.
90, 0, sorry.
And then 180 minus 1.
Mm-hmm.
And then 217, 0.
Mm-hmm.
And then 361.
Yeah. Is that correct? My drawing of it isn't correct. Should look kind of like that. There we go. If you're stuck, same thing. Cos alpha x. Oh, what did I do there? Hold on. Cos alpha x. Start at 0. Stop at 360. Go up by 90 each time. There you go. 90, 0, 180 minus 1, 270, 0, 361.
Yeah.
Okay. Excuse me. Okay, how about this one? Okay, so when it says like Jane took 2 hours to walk home, would you like draw a line going to like a straight line going towards 7 p.m. to show 2 hours? It says before that she was at the ice rink for 1 hour and 30 minutes.
Yeah.
So this is where she stopped at her friend's house.
Oh right, yeah. Okay, sorry. And then so Jane was at the ice rink for 1 hour and 30 minutes. So is it just like a steady line, like a straight line, just steady until 6:30?
Yeah.
And then after from 6:30 you go to 8:30.
Yep.
And then you just draw such a straight line. Yeah.
That's it. So there's that. Let's see. So for 30 minutes. Okay, how about this one?
So you go from 5:30, just a straight, steady line.
Yeah.
And then You go from 530. I think you go to 7.
Yeah,
It's just a straight line. Yeah.
that's it. That's all there's to it. Very common. Let me see this one. Okay. How about this one?
So do you just do 9 divided by 10? Oh wait, no, wait. No, because it's in minutes, you need to like convert it to hours. So you 10 divided by 60,
Sure.
and then they're like 0.6 or something.
Let's just say 1/6.
And then so then you get 1/6, and then you just do 9 divided by 1/6.
So we want the average speed. Speed is distance over time. What was the distance for the first 10 minutes?
9 kilometers.
What was the speed? No, sorry, what was the time?
It was 10 minutes.
Okay, so it's which we changed into 1/6 of an hour. So yeah, and you could put that in as 9 divided by 1/6,
Yeah.
and I think it's going to be 45. 9 divided by 1/6. Oh, 54. There you go. So 54 kilometers per hour.
Yeah.
Kilometers per hour. There we go. Okay. How do we do this?
So this is just where you like add 3 to all the x's, or -3, sorry.
-3 to all the x coordinates, yeah.
Yeah.
So any obvious new coordinates there, or something you can just get right away?
-20 would be -50.
Yeah.
And then like 0, 4 would be -3, 4.
Yeah, 1, 2, 3. And let's say one more. Any obvious?
Um, -4, 4.
Yeah.
And then I think that's -7, 4.
Yeah. 1, 2, 3. That's good enough. And then do that. Okay. There we go. Fine. So with a curve, it's good to get 3 points. Okay, how about this one?
So minus x. So is this meant to be like minus y coordinates?
Yep.
So is this where it's like so 0, 4 would be 0 -4?
Yeah. And let's get 2 more.
Yeah. So and then -2, 0 would be -2, 0.
Yep.
And Minus 4, 4 would be minus 4 minus 4.
Yeah. And then that's enough there. Okay, best I can do. What transformation is this?
Translation.
Yeah. Oh, sorry. Okay, they want the new equation of g. So this one is y equals the f of x. So what is the equation for this one?
So I can see like 1 point goes from 0, 4 to 6, 4. So is it x plus 6?
What happened for this one when you had x plus 3?
Oh, right. Is x minus 6, I should say.
Yeah, x minus 6. Y equals the f of x minus 6. That's it. It moved 6 to the right, so it's x minus 6. What's going to happen here?
Do you just add 1
To what?
to the x coordinates?
Yeah, and because it's a straight line this time you only need 2 points. I'll take something near the start. That looks like a half. Something near the end. There you go. Jobs are good. That one there. And should be parallel. Looks parallel. Okay, what's going to happen here?
If you had like 0, 4, would it stay 0, 4?
So yes. What is happening here?
You just divide x by 4.
Yep.
And then 4, 4, 0, would it be 1, 0?
Yep.
And then for minus 4, 0, would it be minus 1, 0?
Yeah. And then what question are they asking us?
Work out the length of line segment PQ. Was PQ those 2 points? So is it just 2?
Yeah, so it's 2. That's it. Yeah, because it's where it meets the x-axis.
Yeah.
Okay. That one's alright, same. What's going to happen here?
Do you just times y coordinates by 2?
Yep, so there's a 3, so that's going to be 6. There's a minus 1, that's going to be minus 3. That's still 0, that's still 0. And there's a 3, that's going to be 6. And let's do that. And if you're stuck, if you're really stuck, you can always just write them out in the full way, like 3, 3, becomes 3, 6. But I find it easier to just do it that way. This one, if we have time, I'll come back to it. What's going to happen here?
Y equals sine x plus 2. So I'm guessing all the x coordinates, you just need to minus 2 from them.
That would be if there was a bracket.
Oh, sorry. So plus 2 to the x coordinates.
This here is the same as y equals 2 plus sine x.
Is it the y coordinates minus 2?
What would you get if you put the 2 next to the y?
It'll become y minus 2.
So that'd be y minus 2 equals sine x. So what's going to happen to the y coordinates?
You minus 2. What do you add?
You add 2. Yeah. So because they brought it to the other side, y is already in the form that you do. So with x, it's the opposite. With y, it's usually the same because they've already brought it to the other side.
Yeah.
So they changed y equals into y minus 2 equals, and then they just plus 2 for you. So you're just adding 2 to every coordinate and then joining them up. Any questions there?
No.
Okay, I'll just do my best. There we go. How about this one?
So it would be minus 2 on the y coordinates.
Right. So let's say this one. What's going to happen to that?
So is that's like 0, 1. So would it be 0 minus 1?
This isn't subtract 2. This is y equals minus 2 times cos x.
So is it y times minus 2?
Yeah.
And then so is it 0, 1, 0 minus 2?
Yeah. How about the very left one?
That's minus 180 minus 1. So is it 2?
Yeah. And this one has the same. And these two are the same. What would those be?
They'll be 0.
Yeah. You join those up. Yes. Yeah, so minus 2 cos x, it's already brought to the other side, so it's just times the y by minus 2. It's not in the bracket next to the x. Yeah, minus 2 cos x is short for minus 2 times cos x.
Okay.
Gradient in a straight line, we did this a million times. gradient, we did these. What is this?
So I think it's y equals
Just gradient.
minus. Oh, sorry. So that's just. Is it minus a quarter?
Yeah, that's fine. I think we did it. Okay, how about this one?
So would you like to draw a point like 1 ahead and then the rest is just 2 left, isn't it?
Something like that. Yeah.
And 5 coordinates of 2. So I'm not sure.
Any idea about the coordinates of P?
So I think And that the lines like around P, it's got like 3 and 4.
Uh, yeah. So, um, you have it's 4 up on the Y,
Yeah.
3 on the Z. How about the X?
6.
Yeah. And so, what is the coordinates for O?
Of what, sorry?
For O?
Um, is it just 0, 0, 0?
Yeah. And so, how would you use that to get T?
Um, so our T is going to be 6 quarter as well, or
So T is basically a third of the way along. That's 1/3. That's 2/3.
so do I have to find a third of the 6 or 3?
Yeah.
So is that 2, 4/3, 1?
Yeah. So there's so any questions there?
What's like a vertex?
A corner.
Corner, right, okay, thank
Yeah.
you.
Corner. Polygon is a line, like side, something like that. Midpoint. That's all right. This is the same thing, but it's 3D. Midpoint. I think that's all right. Midpoint. Alright. Do you do 3D stuff?
I think we did it that briefly, but yeah.
Yes, it doesn't come up very much. Alright. And let me just take a look. So that's just midpoint. Yeah, there isn't really very much to it. Yeah, how about this one?
um, so I just running like design a question.
Yeah.
Okay, so did she say on average how often do you travel by train a week?
Okay. No. How? Okay. Yeah, go on.
And do I have to give like answers as well? Or?
Yeah.
Oh, so okay, and then could you say so one box is never.
Yeah.
What one box is like 1 to 3 times.
Okay.
Another is 4 to 6, and then
And
another every day.
I think you would just say 7 or more
Okay.
because it didn't say how many days per week. So it's a bit ambiguous because these could be individual journeys.
Yeah.
So I'd maybe say 1 to 3 hours or something.
Yeah.
So 1 to 3 hours, and then this one I wouldn't say never. I'd just say 0 hours.
Okay.
And there's nothing wrong with doing 0 to 1, but fine. 1 to 3 hours, 4 to 6 hours, and then 7 or more hours. And you can always put the hours up here. How many hours do you train? And you can just do that. You only need 4 to 6 response boxes. 4 is fine. That's exactly the same. Okay, so how about this one?
Um. So if you just said something like, how often do you read books a week, and then on average, how often do you read books a week? And then if you had like 0 hours, and then you had 1 to 3, 4 to 6, and then 7 or more.
So I'd say how many hours
Yeah.
do you read per week? And then 4 boxes and 0 to 1, 2 to 3, 4 to 5, and then whatever comes out as 6 or more. I think that's all right. Any questions there?
No.
Okay, so before you were spotting what mistakes they made, and now you're just doing it for real. Oh, that's way too far back. Okay, I just want to do this. Check this one. Okay, how do we do this?
And is this where I do like y? I draw the line y=2, and then like wherever it meets the little curved line, then those are the points.
Yeah, and how would you do the first part?
The
table.
The table. All right. So is this where you get your calculator?
Yeah.
And then you say table. Also mode. Yeah. Sorry. 3. Then you do 6 minus x squared. And then you do start -4, end 3, and then go up 1, and yeah. And that's all.
So -3, 0. 0, 6, 4. And that is -6. What's next?
Oh, is this where you have to plot? You have to plot those points on the table.
Yeah. So what are the points?
So -4, -6.
Yeah, and I think you'll be all right for the rest of those. -3, 0, -2, 4, -1, 6, 0, 6. Okay, and then 2, 0 is going to be there. And so it looks like it's going to be like that. Okay, what's next? So we've done part A and then part B.
And then when you do find estimate the solutions of the equations, so do you just do, so for y=2, and then you see where it's like hit the point, and then and then you like go down.
Yeah.
And then you'd say, like, I don't know, like x is 1.5 or -2.4 or something.
1.5 or x equals 2.5, something like that. And just do it as accurately as you can with your ruler. So that's x cubed. So that's just, so actually they're much easier then. These are much easier. Okay. What would you do here?
So would you do x? Would you do x -3?
And so what do you mean by that?
Oh, so is it, so with the x coordinates you like -3 from them? So if it was like
that would be if what did we do? Why was this one -6?
Because you.
So we started from the one on the left, and the new one was the one on the right, graph G.
Yeah. So was that previous equation? Was that x minus 3?
Yeah.
So would you add 3 on the x coordinates?
Yes, that's it. Just add 3 to all the x coordinates. Because it's reverse. Gradient, you're alright. Midpoint, you're alright. And then how do we go about this one?
So on average, how many times a week do you play sport?
Okay. Go on.
Oh, wait, should I say moderate? Do you exercise moderately or something like that? Because you might just like do sport for like 10 minutes. You might do sport for like 3 hours or something. So
Okay, so then how many minutes or something?
yeah.
Or how many hours? Or, yeah, how many minutes? Whatever you think. Okay.
Yeah, probably like can we say how many minutes / hours or something?
Okay, so what if you had a box that says 60? Is that 60 minutes or 60 hours?
No. You'd write you'd write 1 hour or 60 minutes rather than 60 minutes.
No. Pick one. Okay, hours.
Yeah, 5 hours. Okay. And then could you say 0 to? Could you say 0 to 0.5?
0 to 1.
And then 2 to 4. 2 to 3.
Hold on. I spend an hour and a half per week.
Oh, it's so exhaustive.
So that's not exhaustive. Let's do minutes. Let's say 0 to what?
0 to, I don't know, 30 minutes.
Okay, so next one.
31 to
Yeah,
it's like 90 or 60, I don't know.
60. The first one went up in 30, so we'll do the same here.
And then 61 to 90.
And the last one.
90 or more.
That's an overlap, isn't it?
Oh, 91 or more.
Yeah, and I left something out of the question up there. What is it?
Oh, a week.
Per week, that's it. Yeah, how was that for you, Andrey?
Yes.
Okay, so we're on to 2 mark data. Good. Any questions for me in general?
I think so.
Okay, well then, Andrey, you're doing great. Look forward to talking to you next time.
Thank you. Bye.
Alright, have a good one.